Hey everybody, these are some solutions coming to you from section 9, assignment 9A3. Let's talk about number 9, the first problem. So they give you these two equations and you can multiply equation 1 by -6. I'm doing that because I already see that I have a 1x right here, and it seems like an easy thing to do to multiply by -6 to get elimination. Positive 6x here, -6 here. It'd be a bit more difficult to do it with the y's. You could technically multiply the top equation by 5 and the bottom equation by 3 to get -15y and 15y, and that would achieve elimination also, but this is a bit easier. So when you do that, you get this top equation times -6 becomes -6x plus 18y equals -2, and then when you add the two together, x's eliminate, and you get 23y is equal to -46. And so there it is. You can actually divide 23y, divide the bottom equation by 23 to get y equals -2, and back substitute into the original unused equation. Not unused in this case, I guess, but if y equals -2, you can put it into either one of the original equations, and there you choose the top one, and you get x is equal to -4. So the solution is -4 comma -2. Number 12, you can see here the solution. You start here with these decimals. The first thing that the textbook does is they multiply all the, both equations by 10 to clear the decimal. It's just a bit easier to do. And once you do that, then you can see 2x and 4x. It might be easy to get elimination here. So you multiply by -2 and then add, and you get 12y is equal to -8. And if 12y is equal to -8, then you can divide both sides of the bottom equation by 12, and you get y is equal to -2/3. Plugging -2/3 back into the other equation, you get x equals 1/2. So there it is. There's the two solutions. Number 16, you can actually divide both sides of the top equation by 7, or as they say, multiplied by 1/7. And so the first equation becomes just a minus b is equal to 2. And then it's just a little bit easier for formatting purposes if you're going to use elimination, to write it, all the variables equal and then the number. So they move the b over to the other side, subtracting b from both sides. You get 2a minus b equals 5. Then you can do it. It seems, I guess, equally easy to eliminate either A or B. They chose to eliminate A because they thought they could get -2A and +2A. So you multiply the top equation by -2, and then when you add them, you get nothing is equal to -b times -2 is +2b, and then plus -b is +b. -2 times 2 is 4, plus 5. -2 times 2 is -4, plus 5 is +1. So therefore b equals 1, and back substitute into the original, you get, or into this, not the original equations, but this particular equation, you get a minus 1 equals 2, so a has got to equal 3. So the solution is 3, 1. We've got a word problem here. White sweatshirts and yellow sweatshirts, a total of 30, and then so this is total number of sweatshirts, and this is a total number of this is a total amount of money. $9.95 for each individual white sweatshirt and $10.50 for each individual yellow sweatshirt, and this is the total amount of money. It's really convenient to think about total equations. Here, this is the total number of sweatshirts, and this is the total amount of money. And so I just, whenever you can, think about total equations or writing total equations. They really lend themselves well to elimination. So looking to eliminate the w's, you can multiply this top equation by -9.95. So then here you get something that when you add these two equations together, you get the elimination in the w terms. And then this y times -9.95 is -9.995. Y, and then 30 times -9.95 is this number right here. You add these two and you get this. You add these two and you get this. And then dividing both sides by 0.55, you get this. Back substitute into the original, you get w equals 8. 43 is a little bit more complex, and I thought this was a slightly different way of going about it. Not too different, but because we know we are dealing with total equations so much, the textbook decided to do our normal table, except they also added a total line here. So you can see t1 plus t2 equals 1. And instead of creating new variables for d1 and for d, what they did was they just multiplied speed times time, or rate times time is equal to distance. So 8 times t1 is this, 4 times t2 is this. And I think that avoided a little bit of work because it also avoids creating another variable like d. So you can see that the total time is 6. You can see here there are equations, total equations. They multiplied the top equation by -8 and added it to the bottom equation to get nothing down here. Like t1 times -8 plus is -8t1 plus +8t1 is 0. t2 times -8 is -8t2 plus +4t2 is -4t2 here. 1 times -8 is -8 plus 6 is -2. Then they divide both sides of the bottom equation by -4 to get t2 is equal to 1/2. Subbing it back into the original, they get t1 is also equal to 1/2. So the distance is going to be, the time is going to be 1/2. T1 and T2 are both 1/2 of an hour. Notice that these are all in kilometers and hours and kilometers per hour.